So this is A-level projectile motion formulae section. It's from mechanics, and this is the last section of projectiles. Okay. So a particle is projected from a point on a horizontal plane with an initial velocity of u at an angle theta about the horizontal and moves freely under gravity until it hits the point plane at point B. So this is your point B. Given that the acceleration due to gravity is g, find an expression for the time of flight t, and part B is the range on the horizontal plane. Okay, so the difference between the questions that you have been doing so far in projectiles until this part is that all the values here are in variables. Okay, there is no values given to us, and the entire formula is going to be calculated based on USU VAT without having any values substituted for. Okay, so let's get started. So here, the first thing we do is we resolve this force horizontally and vertically. Okay, so the horizontal force should be U cos theta, vertical force should be U sine theta. Okay. Part A is asking us to find the time of flight. Now, for time of flight, you need to see whether it's better to resolve vertically or whether it's better to resolve horizontally. Now, horizontal axis, we don't know the distance traveled across. Okay, so it's always better to resolve vertically when you don't know the horizontal distance traveled. So let's get started with that. So if we resolve vertically, what we are going to have, so this is SUVAT, S-U-V-A-T, and the vertical displacement is 0. You started at that part of your plane and you're back at the same place, so vertical displacement is 0. Initial velocity, when you're resolving it vertically, the initial velocity is u sine theta, so let's plug that in there. So that's u sine theta, and then the velocity when it hits the ground, we don't really need to know that. Acceleration, it's falling freely under gravity, so it's g. If you're going to resolve upwards is positive, that's going to be negative g. And time is what we need to calculate, so let's just put that as a capital T. That's what they're asking us to find. So using what we have, the formula that you're going to use is S is equals to ut plus half at squared. Okay, let's sub everything in. So 0 equals, initial velocity is u sine theta, t plus half, and this is a is minus g, so minus g t squared. Okay, we're going to rearrange to make t the subject here, so let's write it down. So factorize the t out of both of those terms, so t into u sine theta minus a half gt. So those are the two sets of values. If it's equals to 0, what you're going to say is t is equals to 0, or that bracket is equals to 0. So let's write it down. So t is equals to 0, or u sine theta minus half gt is equals to 0, which means then t is equals to, take that to the other side and then simplify it. You're going to end up with u sine theta divided by, so a half, meaning the denominator would be 2. Sorry, 1 over 2, so let's put that as 0.5, 0.5 g. Okay, if you want to rewrite that a bit nicely, 0.5, multiply the numerator and the denominator by 2, so denominator, you get rid of the 0.5 from the denominator. Okay, so that's meant to be theta as well, so you're going to end up with u, 2u sine theta over g. Okay, so that's the answer for the time of flight. I'm just going to rewrite that. So the time of flight on the horizontal plane, because you do need to know how to get to it. So time of flight on a horizontal plane, horizontal plane is equals to, so T is equals to 2u sine theta over G. Okay. The second part will be on the next video, so make sure to watch it. Thank you for watching.